Okay, 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 okay. Okay, so within 2-3 minutes, I think we start the session.
I think midweek, so
Hmm?
it's midweek, right? So maybe some like other people couldn't join.
Uh, but anyway, our this solve the session will be on Tuesdays, right? Generally.
Yes, it is generally on Tuesdays, but now it is normally the pattern what we see is this week 10, week 11, and all those things normally get ignored.
Okay, okay. Okay, due to that eligibility is already is there, so
It is
no need.
already done, and kind of the last 3 weeks normally will be a bit lethargic.
Yeah, yeah, yeah. Okay, okay, yeah. Okay, that is fine. No worries. So shall we start the session then?
Yeah, that should be fine.
Yeah, okay. Just give me a moment. I'll share my screen.
Oh, sir, in parallel, math class is also going on actually. That's the reason actually people might join
Okay,
little
okay,
late.
okay. Maths 2, huh? I think
Yeah,
it is
math two.
stop. It
Math
is
two.
done. I think I got the message that
Yeah, it's just to be finished actually.
okay, okay, okay. Maybe they will join. Yeah.
People might join little late. Yeah.
Okay, okay. That was okay. So shall we wait for 2-3 minutes then?
Yeah, that should be fine. Anyway, that should be fine.
Okay, okay. Yeah, yeah. So now they are joining. Correct. Okay. Until people are joining, you can. Are you able to see my screen? Hello.
Yeah.
Yes.
Yeah.
Yes, sir.
So open joinpd.com and enter this code there GZWFEX. So let the other participant join. Until then, you guys please join this joinpd.com. Okay.
Hello, sir. Good evening. Meanwhile, can I ask something?
Okay. Regarding what?
Sir, I have some query. Can I ask?
Yeah, yeah, please ask.
Hmm. Sir, how many weeks will be come in quiz? I mean, final exam.
So mostly see the pattern is whatever the pattern we are following, the same pattern we are going to follow. So mostly from the last 3 weeks, right? Except because 12th week,
9, 10, 11.
since 12th week is a refresher week, so the 3 weeks will be major focus, and remaining some questions will be there from the previous weeks. It will be like that. So you can see that if parameter estimation questions will be there, so including eight
Okay.
also, I'm saying that parameter estimation, Bayesian estimator, hypothesis
Mm-hmm.
testing, and yeah. So that should be the major part of your quiz.
Okay. Actually, sir, these parts are tough, Is it?
No, the hypothesis testing and you can see this parts I think fairly enough, fairly easy, because why? Uh, we have the some procedure there, so you have to follow the same procedure everywhere, right? For the
Mm-hmm.
G test also the same procedure is there. For F test also it is the same procedure. For whatever test will be there for hypothesis testing, the same procedure. But the important part is to uh, understand what is null hypothesis and what is alternate hypothesis. If you are able to find that thing, like uh, uh, if you are able to understand that thing, then it will be easy. Okay. Otherwise it's steps, right? You have to follow the same steps repeatedly, you'll get to the
Mm-hmm.
answer, like that. So it's
Okay.
not that difficult. Similarly, for parameter estimations also, there are two methods, no? Method of moments and ML estimation. So you see, there is nothing in it, right? The same
Mm-hmm.
steps you have to follow, and you will get to the answer. Bayesian estimator, you have to. It is also procedure based only, but the thing is, some more calculations are there. That's it. Apart from nothing. So for this type of things, you have to do a lot of practice. Similar type of questions you have to practice a lot, then you'll get
Mm-hmm.
to so you'll get very easily. See, except that multiple continuous random variables or multiple discrete random variables, this part is, I think it's very easy once you understand the concepts, right? It's not that difficult. You have to follow the same path. Okay.
Okay.
The
So
question will
Sir,
be
is it
like
possible?
we quiz to standard.
what will be the focus?
Yeah.
Can you repeat that?
I said no. So parameter estimation and the hypothesis testing, that will be the major focus. So last 4 weeks.
Ah,
Sir, is
okay.
it possible to take classes after 22, because there is no any classes after 22 March?
Yeah, we'll have sessions. So we'll have sessions there. So we are planning for some on-demand sessions. But
Yes,
yeah,
sir. It would be good
the
if.
schedule and everything will announce it. So those
Mhm.
sessions will be uh, it won't be live streamed. So you can
Okay.
just ask the questions, whatever doubts are there, you can ask there.
Mhm.
I will let you know the schedule regarding that sessions. So maybe
Okay.
one
Yes,
or
sir.
two
Thank
sessions
you.
will be there. Yeah. So
Mhm.
mock test will be there, everything. Um,
Okay.
and a similar pattern will follow. So the quiz too, if you
Mhm.
compare whatever mock test questions will be there, the same concepts were there in quiz, right? If you
Mm.
observe it carefully, so similar templates. So 60 students are connected here. Others joins the sessions.
Hello.
Somebody is Tejasvi Singha is there. So please mute yourself, and others please join the joinpd.com. So I'm going to start the class. So please join it.
This biochemistry is
Can you mute everyone?
So the Tejasvi Singha is there something, to please mute. So now I have enabled that mute all, so you can't be able to unmute yourselves. So please don't do this kind of things in between the sessions. Okay. Um, okay. Others please join the session. Uh, Go to the joinpd.com. Write this code there, GZWFEX. Oh, my voice is low. Huh? Okay. Is it? My voice is low? It's fine. Okay, okay, fine. Yeah. Okay, okay, okay. So I'm going for the first question. Uh, just see this question. Question one is, suppose x is a normal, if x is having a normal mu distribution with mean mu and sigma square equals to 4. For n equals to 100 IID samples of x, the observed sample mean is 11.8. What conclusion would z test reach if the null hypothesis assumes mu equals to 10 against the alternative hypothesis mu is not equal to 10, and use alpha equals to 5%. Alpha is your significance level. So given that x is following a normal distribution with mean mu and sigma square equals to 4, here mu is unknown, that is mean is unknown. We have 100 IID samples and the observed mean, which is a t statistic here, is 11.8. So you have to uh, conclude by using a z-test against the null hypothesis where mu is equals to 10 and the alternative hypothesis mu is not equals to 10. So what conclusion you will made based on the significance level of 5%. You can use this value fz of minus 1.96 equals to 0.025. Please attempt this question. I will give you okay, this is first question, so I'll give you 5 minutes to solve this, and then we'll see the solution. Use joinpd.com here, and this code is GZWFEX. So, okay, contact numbers, huh? Okay, maybe I can give you. mm, I can give you my. Okay, you can connect me to the LinkedIn. It's fine, right? I will accept your LinkedIn request there. Hmm? Okay, you can search this, then you can able to connect me. Okay. Okay. Now you guys can unmute if you wanted to ask me, and you can ask me. Okay. Okay. Only 10 responses I have found here out of 28. Okay. Others are trying. Okay. I'll give you maybe 2 3 minutes more. Okay, there are 97 participants I'm seeing in this Gmeet, and on the joinperiod.com only 28 are there. So others also, if you want, you can join. So it will be better if you join and solve by yourself. That will be the better practice than just seeing the questions and seeing the solution. So if you try and if you don't reach to the answer, that is fine. Then you will get to understand where you made the mistake or something like that, right? So it will be better if you join joinpd.com and try to solve the questions by yourself. Okay. It does not matter if you get the correct answer or not, because while solving you'll get to know that where you are doing the mistake. Otherwise, you don't know where you can do the mistake, right? If you just see the solution, it doesn't help that way. So it's my suggestion that if you can join, please join this joinpd.com. Okay. I got 15 responses out of 28. Okay, I got 17 response out of 30. I don't know, like, you guys are trying. So others who you have joined already, joinbill.com, you guys are trying, or shall we move to the solution? So are you guys able to unmute yourself, right? Mm, no? Okay, just a minute, just a minute. I will change the settings. Yeah, now you check. Hmm.
Yep.
Yeah, now, right? Okay. So anyone wants, like, I don't know, shall we move to the solution?
Yes. Yes, please.
Yeah. So we'll see the responses first. So out of 18 responses I got, 14 said reject H0 and 4 said accept H0. Okay. So we'll see the solution. So given that X is a distribution which is normal mu 4 where mu is unknown, and x1 to x100 are the IID samples uh, following this distribution X, right? And we are given the sample mean X bar as 11.8 with the significance level alpha equals to 0.05. We have to test the null hypothesis mu equals to 10 against the alternative hypothesis mu which is not equals to 10, right? So here, what is our test statistic here? It's x bar minus mu, right? X bar is a observed mean minus your distribution mean. That is, you have to test, right? Then our test is reject H naught if mod of x bar minus mu is greater than c, right? And c is the critical value. Given that x is normal mu 4, uh, for 100 IID samples, X will okay. What will be the distribution of sample mean? Given the distribution, the population distribution, uh, following normal mu 4, then for 100 IID samples of X, the distribution of a sample mean is normal mu 4 by 100. Correct? This step is correct. Everybody is okay with this step?
Yes, sir.
Okay. Now, okay, just give me a moment. Huh? Okay, sorry guys. So we have given the significance level or alpha, the value of alpha. So what will be alpha? So alpha is probability that will reject H naught given that H naught is true. So our H naught, which is another hypothesis, is what? Mu is equals to 10. So when we are going to reject the H naught? When your test statistic x bar minus mu is greater than some c, right? So this is shown in the first line of uh, our first line here on the screen. Now we have to convert it into z distribution, right? A normal 0 1 distribution. So how to convert, you know that. So it will be x bar minus mu, it is there, divided by what? Sig Divided by this stand standard
Standard
deviation. Yeah, sorry, standard deviation. So what is our standard deviation for the sample mean? Is 2 by 10. How it came? It's because sigma square is 4 by 100. So root of this 4 by 100 is 2 by 10, right? This step is okay. The second one. So it will be the mod of x bar minus mu divided by 2 by 10, which is greater than c upon 2 by. So what we did is we divided by the standard deviation on both the sides, left hand side as well as right hand side. So you'll get this. So this x bar minus mu upon 2 by 10 is nothing but what? Z, right? It's a Z normal distribution, normal 0 1 distribution. So probability that mod of Z is greater than C upon 2 by 10, which is nothing but 5C, okay, which is equals to alpha, and alpha is what? 0.05. It is given in the problem. So 0.05 is equals to probability that mod of Z greater than 5C, and you know that if mod of Z is greater than 5C is nothing but 2 times fz of 5C, correct? 2 times fz of 5C, right? Now, okay. Root of, sorry, not root of, 2 times probability of Z is less than minus of 5C. Okay. So are you guys following me? I'm not sure, like,
Yeah, yes, yes.
yes, no, okay. So if you calculate this thing, so you'll get minus 5C equals to minus 1.96, and this fz of minus 5C is given in the uh, okay, in the question what is given here, fz of minus 1.96 is 0.025. So fz inverse of 0.025 is minus 1.96. So here if you see, 0.025 is equals to fz of minus 0.5c, right? So if you take that fz inverse of 0.025, it will be minus 1.96, and which is equals to minus 5c. So that minus minus will get will become positive. So 5c is equals to 1.96, and the value of c is equals to 0.392. We have to check the c is greater than our test statistics or not. So x bar is given here 11.8, and we are checking against the null hypothesis of 10. So 11.8 minus 10, which is 1.8, is greater than 0.396, which is c, right? So that means we and what was our test? If our t statistics is greater than c, the critical value, you are end up rejecting the h naught. So here 1.8 is greater than 0.396, so we are rejecting null hypothesis here, right? Okay. So this same procedure you have to follow for the next questions also. Only the context will be different, and you have to check for that, like how you are going to use that values there. Okay. So the second question is: it is claimed that the lifetimes of light bulbs are normally distributed with mean of 100 hours and standard deviation of 2 hours. We wish to test the hypothesis that mu is equals to 100 against the alternative hypothesis mu is not equal to 100 with a sample size of 9. So here also it is somewhat similar to the previous problem, only the change is acceptance regions we are changing here. So here the acceptance region is between 98.5 and 101.5. So this is the observed sample mean for this uh, how many numbers? Okay, we did okay for 9 uh, bulbs, or the sample size of 9, we have the acceptance region between 98.5 to 101.5. So you have to find the significance level, that is value of alpha here. Use fz of minus 2.25, which is equals to 0.012. Okay, please solve this question. Okay, I'm seeing 10 responses out of 33. So, are you guys like trying it, or are you facing any problems in solving or something like that? Or shall we see the solution for this question, and then maybe it will be clear to you? Mm. Hello. Uh, I'm not able to like hear any responses from you guys. What's the problem?
Just 1 minute, sir.
Okay, you guys are trying. Okay, 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 fine.
Yeah.
Yeah, yeah, yeah. So, while solving these questions, if you have prepared some notes or something, right, you can uh, put like without you can see that and you can try to solve. That approach also will be good approach. But please try to solve. That's what I wanted to say. Okay, last 2 minutes I will give, and then we'll see the solution. Okay. Okay. Okay, I got 15 responses. We'll see the responses first. Okay. So answers like 0.024, 0.0244, 0.976, 0.024, 0.97. Okay, so the two common answers are there. It's 0.024 and 0.976, right? Okay. Okay. Three people have given 0.976 as answer, and others I think have given 0.024. Okay, we'll see what's the correct answer and how to solve this question. Okay. Okay. So this is so what we have given here in the question. We have given that the random variable x, which denotes the lifetime of a electrical bulb, and it follows a normal distribution with mean equals to 100 and standard deviation equals to 2. That means variance equals to 4, right? 2 square. And for n equals to 9, so that 9 IID samples, we are going to test for null hypothesis, which is mu equals to 100, and alternative hypothesis mu is not equal to 100. So all of you have able to uh, find this step, like what is the null hypothesis and what is the alternative hypothesis. All of you are able to find out like this step,
Yes, sir.
all of you. So there is no issues in finding out null hypothesis and alternative hypothesis, right? Okay. I'm assuming that you guys are understood like how to find null hypothesis and alternative hypothesis. Okay.
No, no, sir. Can you explain,
Yeah.
please?
Okay. Okay.
Yeah,
So
please.
yeah, wherever there is a doubt, you just ask me,
Yeah,
stop me
please.
there, and we can.
Yeah, yeah, please.
So here actually it is given in the problem itself. Since if you see, it is claimed that the lifetime of electrical bulbs are normally distributed with mean of 100 hours and a standard deviation of 2 hours. So given that, so suppose your random variable x is lifetime of light bulbs, and what is given in the question, mean of that lifetime is 100 hours and standard deviation is 2. That means variance equals to 4, and we used to test the hypothesis that mu equals to 100. So here it is given that we are going to test for the hypothesis mu equals to 100, which is our null hypothesis. Okay, what I told you is generally null hypothesis will be a simple hypothesis, right? I think one of the sessions I was telling about what is simple hypothesis and what is composite hypothesis. So generally your null hypothesis will be simple hypothesis, even if it is not given in the question. So okay, in this question it is given that mu is equals to 100. We are testing for mu equals to 100. That is our null hypothesis against the hypothesis. So we are testing against some other hypothesis, which is alternative hypothesis, which is a composite hypothesis. You can see here, which is mu is not equals to 100. That means either mu is greater than 100 or mu is less than 100. So this is mu is taking the range of values, right? Greater than 100 and less than 100. So this is composite hypothesis. So we are testing against this hypothesis, and hence it is an alternative hypothesis. And mu is equals to 100 is your null hypothesis. Suppose it is not given in the question, because here it is explicitly mentioned that mu is equals to 100 and mu is not equal to 100. So you can understand directly that it is a null hypothesis, mu equals to 100, and alternative hypothesis mu is not equal to 100. But suppose if it is not given in the question, and it is said that it is claimed that the lifetime of light bulbs are normally distributed with mean of 100 hours and a standard deviation of 2 hours, we wish to test the hypothesis, and we took the sample size of 9 bulbs and the observed mean of the sample, right? The observed mean of the sample is given something else, suppose 110, something like that, so which is greater than 100, right? So in that case your null hypothesis will be mu equals to 100, because it is claimed that mean should be 100 hours, right? So it is claimed that 100 mean is should be 100 hours. That means your population distribution is, it should have the mean lifetime of 100 hours, right? So that is your null hypothesis then. And this observed sample mean is given that the lifetime of bulbs exceeding 100, so that is mu is greater than 100, right? So your alternative hypothesis in that case will be mu is greater than 100. We'll see that kind of problems also. So now you understood, right? Why we have taken mu equals to 100 and mu is not equal to 100. It is
Yep,
already given in the question.
yep, yep.
Okay.
Yeah.
So what we have to find is we have to find the value of alpha, that is significance level. So what is significance level? It is a probability that reject H naught given that H naught is true. Okay, and we have given the acceptance region here. So for the observed sample, your observed sample mean should be in between 98.5 and 100, 101.5. And you know that when we are rejecting H naught, that means what region we are looking at? A complement, right? If you suppose your acceptance region is denoted by A, then your A complement will be what? Rejection region, right?
Yes.
Everybody is following me? So you guys have any doubt
No,
with
no, no.
the statement?
What is that last thing?
Okay, so here if you see in the question, find the significance level if the acceptance region is
Right.
98.5 and so your
Between these two.
yeah,
Yeah.
between these two, right? So this is our acceptance region.
Yeah.
So if your mean lies between this, then you are going to accept
Yeah.
your null hypothesis, which is what? Mu is equals to 100, correct?
Yes.
And what is alpha? Alpha is reject your null hypothesis given that null hypothesis is true. So in which region we are going to reject this claim, which is
Uh,
mu equals to 100? Outside this region, right?
yes.
You're
Yes.
getting my point?
Yeah. 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 Yes.
Because when we are going to accept that the mu is equals to 100, when your observed sample mean, right, that for 9 sample size, right, if comes between 98.5 and 100 and 101.5, then we are going to accept that thing, right? And
Mm-hmm.
if it is lying outside, then we are going to reject, right?
Yeah.
That is our
Right.
test, that is our
Yeah.
test here. So
So,
what is alpha? Alpha here it is reject H naught given that H naught is true. So what will be your rejection region in this case? If your acceptance region is between 98.5 and
yeah.
100.5,
Yeah.
then
It will
what
be
will be?
less than 98.5 and greater than 101.5.
Yes, yes.
Yeah.
So either
Yeah.
it will be less than 98.5 or it will be
Greater
greater than
than.
101.5. So that
Yeah.
is written in the second line. If you see here, it is probability that your X bar should be greater than 101.5. Then we are going to reject that claim where mu is equals to 100, right? Or when your X bar is less than 98.5, then we are going to reject that. Given that your alternative hypothesis is true, that means mu equals to 100. So how can we solve this? X bar is greater than 101.5 and X bar is less than 98.5. So you so if your mean is 100, then you can see that 101.5 and 98.5, what is the difference there? Difference of 1.5, right? So this line, are you getting this line? uh, or, or else what I'll
Yes,
do
sir.
is, maybe if you
Yeah. Yeah.
otherwise just give me a moment, I will try to draw a region. That will be better. Okay, just give me a minute. Okay, 1 minute, I'll show you some here. Okay, you guys are able to see this screen, right?
Yes, sir.
Okay, so our null hypothesis is 100, right? When mu is equals to 100, we are testing for this mu equals to 100 against the alternative hypothesis that, sorry, HA. So this is your null hypothesis because we are testing again, testing for mu equals to 100 against this alternative hypothesis where your mu is not equal to 100, and our acceptance region is when the observed sample mean. So we have 9 samples, right? 9 IID samples in this given problem. So when our acceptance region, which is denoted by A, is between 98.5 and 101.5, right? So if I try to draw
Yep.
this on this line, so if it is mu equals to 100, then what will be your acceptance region when mu is equals to 101.5 and 98.5? So this is your what? Acceptance region, right? And our alpha is equals to what? Probability that reject H naught, given that H naught is true. Hmm? So reject H naught means when we are going to reject your null hypothesis, when your observed sample will lie in this region, right? Which is less than 98.5 or greater than 10. So what, whenever if your sample mean comes in this region, the red color region, you are going to reject the null hypothesis. That is, you are going to reject the claim that the lifetime of the bulb, the mean lifetime of the bulb is 100. Correct? Now, uh, that means your x bar should be either greater than 101.5 or your x bar should be less than 98.5. So I can write this, right?
Yeah.
Mod x bar minus 100 is greater than 1.5. So how can I write this? What do you mean by this mod of x bar minus 100 is greater than 1.5? If I'll remove this mod, how either it will be x bar minus 100 is greater than 1.5 or x bar minus 100 is less than 1.5, right? Minus 1.5. No, is less than 1.5. Correct?
Yes. Yes. Yes.
So so this is the same as that of this, right? This
Yeah.
thing, and this thing is same as that of this.
Yes.
So that's why the probability that mod of x bar minus 100 is greater than 1.5, we have to solve this now. Now, how can we convert this into normal 0, 1? That is z, fz, right? How can we convert now this thing? Uh, you have to,
Divide
what you have to do?
Divide by sigma by
by
root.
sigma.
Yeah, right? You have to divide it by the standard deviation.
Standard deviation.
For what?
Sample.
For
Sample.
sample, yes.
Yeah.
So given in the
It
problem,
is.
it is a distribution standard deviation, right?
Yeah.
Right. What is that? What is the value for that?
What is
Okay, maybe I'll check if you
2?
get 2, right?
Yeah.
So sigma is 2 given. Uh, then what will be the standard deviation for the sample? Then
Sigma by root.
root 9, right?
Yeah.
So it
Okay.
will be 2 by 3.
2 by 3. Yeah.
So if I divide it by 2 by 3, this entire equation will become equal, which is approximately becomes normal 0, 1, right? Correct? Okay.
Yes, sir.
And
Yes, sir.
to make both the sides equal, what you have to do? You have to divide it by 2 by 3 this side also. So this is what? This is standard normal variate, which is denoted by z. And okay, so what I have to find is mod of z is greater than what is this? So it will be Srishti Tiwari. Can you mute yourself? Otherwise, okay. If I'll hear that voice once again, I will throw out of this session. Okay. Okay. So it will be 3 into 1.5 divided by 2. So I think it's 2 into 1.5. So it's 2.25, right? It's greater than z. So okay. One more thing. Yeah. Probability that mod of z is greater than 2.25, which is nothing but what? 2 times probability that z is less than minus 2.25. Correct, na?
Yes, sir.
And we have given this value, right? So this is 2 times fz of minus 2.25. So we have given in the question this value. Correct? the answer should be 2 times fz of minus 2.25, and the value of fz of minus 2.25 is what? 0.012. So 2 into 0.012 is 0.0244. So that should be the correct answer. Now you
Excuse
guys
me,
understand?
sir.
Yes.
So can you explain me the step probability of mod z greater than 2.25, and after that how it came 2 into probability of z less than
Okay.
minus
Okay.
2.5?
Okay. So okay. This made. I think why I skipped that, because I think we have used that same thing in the previous weeks also, right? Okay. Still, I'll.
Sir,
So
but
why?
I'm unable to
Okay.
recall
Okay.
it.
Okay. That's fine. That's fine. So it is 1.5. No. What is this? 1.5 or 2.25? 2.25. Okay.
2.25.
So first of all, tell me what is mod of z is 2.25. How can I write this? So it will be either z is greater than 2.25 or
Z less than minus 2.5.
right.
So minus sign should be there or not?
Yeah, it should be minus, no? Then it will become the same. Yeah, correct. Now,
Yes.
you know what is this? Z is greater than 2.25,
So it should be right side to the
right?
2.25.
So if Z this side, no?
Yes.
This side of this. So this total entire area under this curve is 1, correct?
Yes,
Minus
sir.
this. So it will be minus fz of 2.25, correct? No?
Yes, sir.
So it should be what? 1 minus fz of 2.25. Okay.
Yes.
And what is this?
Fg of minus 2.25.
So this region. So this is okay. So actually, what we are interested in these two regions, right?
Yes, sir.
So this area means like this thing, and this thing is similar. This area,
Yes, sir.
since
Yes, sir.
it is symmetric, because it is mu 0 1 curve, na? Because here it is mu 0 1 curve.
Mm.
So these two regions are symmetric, right?
Yes, sir.
So I can write directly 2 times here, 2 times fz of minus 2.25. Since
So,
this
sir,
will,
this 1 minus Fg of 2.25 is equal to Fg of
yeah,
minus
yeah,
2.5.
because it is symmetric, no?
Yeah, yeah.
1 minus this thing also, it will give you
Hmm.
the same thing, and this also it will give you the same thing. That's why I'm what I'm directly doing is I'm just multiplying these two things, because the area under these curves is similar. That's why I'm directly using it 2 times. You can actually prove also this thing, but uh, by visualizing also you can say that, right?
Yes, sir.
Okay.
So, can you show me the question once?
Yeah.
Oh, okay. Thank you, sir.
Okay. So yeah. So the next question is okay. This is a sub question of question number 2 here. So same thing is there as that of previous. Just the difference is you have to find the power of the test. Given that alternative true mean life is 103 hours. Okay. So you have to test against HA equals to 103. Hmm? Okay. You have to find the power. Just try to solve that. Okay. Okay, guys, can you hurry up? So I got only two responses out of 35. We have a lot of questions to do, so be quick, be fast, so that we can see a lot more questions. Okay. So any difficulties here finding out? Okay. 2 or 3 more minutes, and then we'll see the solution. Okay, guys. So we are going to see solutions. Only four responses I got. I think uh, you're finding some difficulty in. I don't know. Like, we'll see. We'll see the solution. Okay. We'll check. So the power is 1 minus beta, and it is a probability that reject H naught given that HA is true. So given that the alternative hypothesis is true, you have to reject H naught. So when we are going to reject H naught, that is A complement, right? That region. Correct, no? Please say something.
Yes, sir.
Yeah, okay. So so in the previous problem we saw that in which region we are going to reject H naught when x bar is greater than 101.5 or x bar is less than 98.5. But here alternative hypothesis is mu is equals to 103. So we are testing against that, right? So if you split it out, then it should be x bar. So same thing you can see here, but why we are splitting it into two? One thing is it's or, that is okay. Previously also, but we did two times fg of the minus 2.25, right? Here, why we are not able to see? Because one, if you check against 103, so 103 minus 101.5 is what? It's minus 2.25, right? And 98.5 minus 103 is okay. And divided by 2 by 3, it's minus 6.75. Are you getting what I'm saying? Mm,
No, sir.
huh?
Yes,
No,
sir.
Yes,
sir.
sir.
Okay.
So can you explain it once again?
Okay. Okay. So similar thing we are going to do here, but we are checking against alternative hypothesis, right? Because we are going to find the power of a test. So here, uh, your h naught is mu is equals to 100, ha is mu is equals to 103, right? And your acceptance region was what? 98.5 is less than or equal to x bar less than or equal to 101.5, correct? Now, if you see on this graph, I'm sorry, okay, here, if you see, so your 103 is here, right? And your, suppose mu is 100, it is here, and where is your acceptance region is this one, right? Here it's 98.5, and here it is 101.5. So we are testing against the alternative hypothesis when mu is equals to 103. So this is your distribution, no? This is your acceptance region, right? And
Yes, sir.
right, and this is your rejection region, right? Whatever this side is there, and so suppose this is your, what I'm saying is, if it is 100, if when mu is 100, then this is your uh, distribution for what? Null hypothesis, correct?
Yes, yes.
And 103 mu, so there should be some distribution, no? Here is your distribution for alternative hypothesis.
Alternative. Yes, sir.
So which region is power? Will reject, power is 1 minus beta, will reject h naught, right? Given that ha is true. So when we are going to reject h naught? In the a complement region, right? In this red region, correct, no? Red region
Yes, sir.
here. So in a complement region, that means when x bar is greater than 101.5 or x bar is
Less
less
than
than
90.
0.5, given that when h is true, h is mu equals to.
102.
So this, or I can write like this, right? By using the properties of probability. This is probability, no? So by using the properties of probability, I can write x bar is greater than 101.5, given mu equals to 103, or means plus probability that x bar is less than 98.5, given that mu is equals to 103. I can write it like this, right? By using the properties of probability.
Yes, sir.
So that is what written here. Okay.
So why we are not doing two times of that? In
Yeah,
previous
because
question we did.
to say that it's two times, okay, tell me, this is not symmetric, no? So 103 minus 101.5 is how much? So previously what happened is, in this region, this was the value, no? This was minus 2.25, this was 2.25. So
Okay,
this
okay,
region
okay,
was
sir.
similar.
I understood.
But here this region is not similar, right?
Not
These
similar.
values are
Yes, sir.
different. That's why we are not
Thank you,
using
sir.
two times. You can use two times or you can use separately also. That is both the way it's fine only, right? It will give you the same answer. So here probability that x bar minus 103 divided by 2 by 3 is greater than what? 101.5 minus 103 upon 2 by 3. So these steps you understood, right? This,
Yes, sir.
yeah, this is, so similarly you have to use for second. So that value will be equals to z is greater than minus 2.25 plus z is less than minus 6.75. So it is like 1 minus fg of minus 2.25 plus because if it is greater than minus 2.25, that means 1 minus fz of minus 2.25 plus z is less than minus 6.75 is fz of minus 6.75. So the probability becomes approximately equals to 0.987, and that is your power which is asked in the question, right? Okay, so we'll move on to the next question. This is question number 3. Okay, now a commonly prescribed drug for relieving nervous tension is believed to be only 40% effective. To determine, so here you, okay, I will finish up the question first, and then I'll ask you about the null hypothesis and alternative hypothesis. So to determine if a new drug is superior in providing relief, suppose that 100 people who were suffering with nervous tension are chosen at random and inoculated. If more than 50 of them are found to be relieved, we reject the null hypothesis that p is equals to zero point 0.4, and the new drug will be considered superior to the one currently in use. So we have to find probability of type 1 error. So what is type 1 error? What is the probability of type 1 error?
So it's rejecting null given null is true.
So what we are going to say it is alpha,
The significance level.
yeah, or significance level, or a size of a test. Okay, and what is probability of type 2 error? It's beta, correct? Probability of type 2 is error is beta, correct? No?
Yes, sir.
Okay, yeah. So tell me what is the null hypothesis in this case by using by seeing this question.
So it's null hypothesis P is equal to 0.4.
Correct. So how you found it?
Because in question they have given we reject the null hypothesis that P is equal to 0.4.
Okay, yeah. And if it is not given also, so in the first line you can see that
40%. Yeah, 40%.
so it is my claim that this drug, or a company claims, right? Some company is there and it is claiming that this drug is going to relieve this nervous tension for 40% of the people. So that means it is automatically p is equals to 0.4, right? And what is n here?
So it is
100.
100.
100, yeah. And what will be our acceptance region?
Acceptance region is less than 40.
Greater than 50.
Greater than 50, right? If so, no, so correct. So less than 50, right? Because if more than 50 of them are found to be relieved, then we are going to reject the null hypothesis. So rejecting null hypothesis means a complement, correct? Na? Correct?
Yes, sir.
Yeah. And in the question, the hint is given as use normal approximation to binomial. So this is a binomial case, right? With probability of success is 0.4. Right. So there are 100 people. So every person, either it will be relieved or it won't be relieved. So there are 201 conditions there, and we are checking for 100 people. So this is a binomial distribution. So use the normal approximation to binomial. That means you have to convert that binomial distribution to normal approximation. How we are going to convert it? Can anyone tell me?
What's that? Can you repeat it?
How to use normal approximation to binomial? That
Yes,
means
sir. For normal, the mean is n into p and variance np into 1 minus p.
correct. So that will be your binomial distributions mean and this uh, variance, right? Then you
It's
have to
not
convert it by
normal
using
distributions mean.
so yeah. So how can we do that?
So here p is equal to 0.4 and n is equal to 100. So the mean is 40.
Correct. Yeah.
And the variance is 0.4 into 0.6 into 100, 24.
Correct. So then we have to use this central limit theorem again, right? To convert it into normal 0 1, right? Z, right? Fg of that Fg of 2. So given the value Fg of 2.04, it's 0.979. So first of all, find the probability of type 1 error, that is alpha, and find probability of type 2 error for alternative hypothesis, which is p equals to 0.6. So it is beta. So first of all, you have to find alpha. then you have to find 1 minus beta, and then you can calculate the value of beta. Because if you find value for 1 minus beta, then what is the value of beta? It will be 1 minus that value. Okay, so just try it out.
Excuse me, sir.
Yes.
So here, alternative hypothesis would be p greater than 0.5.
Correct. Yes.
Okay, and null is p equals to 0.4.
Correct. Null is, anyway, null is given there, so alternative will be greater than 0.4. Okay, so I got six responses. Let's see the responses first. Okay, you have entered one value, I think only 0.021. So I think that will be correct answer. But this is a value for probability of type 1 error, right? You have to find a value for type 2 error also. So how can you enter this value? Maybe you can do comma separated value if it is possible there. I don't know. It's possible or not. Okay, take 2 minutes and then we'll discuss the solution. Okay, shall we discuss the solution then? Or anyone is trying this question out? Okay, I don't know. Like you guys are very silent. I don't understand. Am I audible?
Yes, sir.
Okay, at least for the
Yes, sir.
okay. What is the problem? Like I'm not sure. Like why you guys are not trying? Like very few people are solving these questions. Uh, solving.
Sir, I have not watched the videos that I didn't have had any time to watch this time because of the exam. So I'm still in office. I have to go back home and then see all the office and then
Okay,
call
okay,
myself.
okay,
Sorry.
okay, fine. Yeah. Okay, so then we'll see the solution then. Maybe that will be helpful. Okay. Okay.
Yes, sir.
So yeah, given that P was so your null hypothesis was uh, probability of that success to be effective is P equals to zero point 0.4, and we are checking against the alternative hypothesis where P is greater than zero point 0.4, and the critical value given here is C equals to 50, and the test statistics T is binomial 100P. Correct? Right now, and binomial using the binomial approximation, that means you have to find the mean for the binomial distribution and the variance for binomial distribution that will follow the normal distribution. So it will be n into p, which is 100 into p, and that is the mean for what? Binomial distribution, right? And variance is 100 into p into 1 minus p. So that 100p and 100 into p into 1 minus p is approximated to a normal. Okay, this is called as a binomial approximation to the, sorry, normal approximation to the binomial distribution. So our test was to reject reject null hypothesis if your t statistic is greater than your critical value. So here critical value c is 50, because we are saying that we are going to reject the null hypothesis for more than 50 people, correct? So that 50 is your critical value, right? Now you have to find a probability of type 1 error, which is what? Alpha, which is probability that t is greater than 50 given that your p equals to 0 0.4. So again, how can we convert this t is greater than 50 into this z, standard normal variate? By subtracting mean and dividing it by standard deviation, correct, right? So mean here is 100 into p, and p is 0 0.4 here. So 100 into 0 0.4. So 50 minus 100 into 0 0.4 divided by root of 100 into zero point 0.4 into zero point 0.6, which is 100 p into 1 minus p. Okay, so one this combined value is that 50 minus 100 into 1.4 divided by root of 100 into zero point 0.4 into zero point 0.6 is 2.04. So if z is greater than 2.04, how can we are writing how can we write probability that z is greater than 2.04? It is 1 minus fz of 2.04. So it is 1 minus, and we have given the value for fz of 2.04, it is 0.979. So it is 1 minus 0.979, which is equals to 0.021. Okay, so that is your probability of type 1 error. What is probability of type 2 error here? So it is because your power is reject h naught given that your alternative hypothesis is true. So it is 1 minus beta. Power is 1 minus beta. So what is beta then? Accept h naught given that ha is true. That is alternative hypothesis is true. So that is probability of type 2 error. So uh, when we are going to accept h naught in acceptance region, when your t is less than the critical value, so which is t is less than or equal to 50, given that alternative hypothesis p equals to 0 0.6. So probability that t is less than or equal to 50 given that p is equals to 0 0.6. So we can say that probability that z is less than or equal to so again we are converting into this standard normal variate. So it will be 50 minus 100 into zero point 0.6 divided by 100 into root of 100 into zero point 0.6 into zero point 0.4. So that value comes out to be minus 2.04. Again here it is z is less than or equal to 2.04 minus 2.04. So we can write it is directly fz of minus 2.04, and the value for fz of minus 2.04 is given, it is 0.02. So correct answer is 0.02. So the correct answer for probability of type 1 error and type 2 error is same. Okay, understood, right? So we are going to
Yes.
the next question. So question number 4 is the proportion of adults living in a small town who are college graduates is estimated to be p equals to zero point 0.4. To test this hypothesis against the alternative hypothesis, which is p is greater than zero point 0.4, you decide to take a sample of adults from the town. Okay, now so this is the kind of similar question, right? As that of question number 3. Here probability of success, which is a proportion of students, is zero point 0.4. This is what your null hypothesis. What is your alternative hypothesis here? When p is greater than zero point 0.4. Okay, so it is kind of similar, but the question here is, question number 1 is, what sample size do you need for a test against an alternative hypothesis of p equals to zero point 0.6 at a significance level of 5% and power of 95%? So here be careful, what is power here? It's 1 minus beta, which is reject h naught given that ha is true. Okay, and what is ha here? Alternative hypothesis is p equals to zero point 0.6. So same question is there, only the difference is n is we have to calculate for n. How can we calculate n? So you will get two equations, right? Because a significance level is given, which is 5%, which is alpha. So from alpha you will get one equation. From 1 minus beta you will get one equation. Then and then you can solve it for your p sorry n. Why we needed two equation here? Because there are two unknowns. One unknown is what? sample size, which is n, and another unknown is what?
Sigma.
Value of c. Correct, na?
Yeah.
Here we don't know what is acceptance region, so we only know that t statistic is there. So these two values are unknown, so we are getting two equations by using significance level and by using power, and then we can equate and solve it for n and c here. Okay, so first of all, question 1 is find the sample size, that is n. Second question is find the critical value at a significance level of 5% and use the below values of fz. It take 5 minutes again. So I think this is the same question from the previous one. Again, you have to use the binomial approximation to normal. Okay, so or normal approximation to binomial, and then you have to solve it. Just solve it. I'll take some 5 minutes and then we'll see the solution. Okay. Hello guys. Okay, I'm seeing two responses only. Anybody is solving, or shall we move to the solution? If someone is solving, I'll wait for 2-3 minutes more.
So we can move to the solution.
Sure.
Yes, sir.
Okay. Why? Huh? Yeah. Okay. So okay, you guys haven't seen the lectures or what? I'm not understanding. Okay, fine. So we'll see the solution. So yeah, this thing is clear, right? What is your null hypothesis and what is your alternative hypothesis? It is already given in the question. So our null hypothesis is when p is equals to 0.4, and alternative hypothesis is p is greater than 0.4. We have given the value of alpha, that is significance level, which is equals to 5.5%, and power is equals to 1 minus beta is sorry 95%. So the test statistic is t equals to binomial np, correct? How we are saying that it's binomial np? How can we say that this is a binomial distribution by seeing this question? Because because the proportion of adults living in a small town who are college graduates is estimated to be p equals to zero point 0.4, right? So that means uh, the person in the town is a graduate, is either a college graduate or not. So there are only two outcomes for each person, right? And there are n number of people are there. So that means it's a binomial n with probability of success. So probability of success here is the person is a college graduate or not. So probability of success is if a person is a college graduate. So from this we can say that it is a binomial NP problem. So uh, what is the normal approximation to this? So the mean is n into p, variance is np into 1 minus p. So if it is normal np comma np minus 1 minus p, this is your normal distribution. Your t statistic here is for x bar equals x bar, that is observed sample mean is normal, it belongs to this distribution normal p into 1 minus p by n. So why it is? Because we are just dividing it by total number of samples, right? It is okay if you are not doing this step here also, that t is x bar which belongs to this distribution. You can do it later on also, that is also fine. So alpha is equals to probability is greater than x bar is greater than c, given that p is equals to 0.4, because it is a significance level. So I have already iterated 2-3 times that what is alpha? Alpha here is reject h naught, given that h naught is a true. So when we are going to reject h naught, when your t statistic is greater than some c, some critical value. So it will be x bar greater than c, given that p equals to 0.4. So we can convert this into standard normal variate, that is normal 0 1. How can we do that? We are just subtracting mean, which is p, from x bar. So x bar minus p, same thing we are doing on the right hand side, where c minus p, then divided by the
Discussion.
standard deviation. So it will be root of p into 1 minus p upon n. So both the sides same, right? So that's x bar minus p upon root of the standard deviation is nothing but z. So when the
Correct.
probability, what are you trying to say something?
Yes, sir.
Hmm, hmm.
Here, why we are dividing by n?
Because so see here, your t was binomial np, correct? So approximation to
The
the
P,
normal is
P is number of people, right?
t is number of people, right?
So how come average will come?
So average number of people who are college graduates in the town, that is possible, no?
Just if we add means we won't get that. For example, if two people means just x1 plus x2.
Uh, yeah, but the thing is, generally Z test is for what? Sample mean, na? So actually, there are the tests we are using, right? So maybe in the next week, you are getting you'll get to know that there are some other tests also are there. Okay, so if your Z test is uh, uh, Z test when we are using Z test for sample mean. So there are certain tests. There are for sample variance, or when the variance is unknown, when the mean is known. So here we are testing against the sample mean. So we have to check for the sample mean only. Then only it will convert into that z-test problem, right? That's why we are doing that. We are going for the observed sample mean. Okay.
Here, can you go to the question once more?
Mhm.
Is here the proportion of adults living in a small town, right?
Mm, mm.
So
Correct.
in a town, 40% are adults, right?
No, no, no. The proportion of adults in a town. So suppose there are 100 people, 100 adults in a town, out of which 40% are college graduates.
Yeah, 40% are college
College
graduates.
graduates. Out of all the adults, 40% are college graduates.
Yes, sir. In one of the lectures, sir, last lecture, 10.8, sir was explaining about that vaccine hesitancy. In that, he has done without that dividing by n.
Mm,
Here, there 20% of people are vaccine hesitant, and
mm,
we have to find.
mm.
Can you go to that slide, sir?
Okay, I think I have to find it, right?
Slide 39 out of 67.
Mm, okay, I need to check. I think again I need to go to that portal. So okay, okay, tell me, okay, because it will take some time, right?
Yes, sir.
So
There, sir, hasn't divided by n.
sir, okay, but if you don't divide it by 10 also, then it will be the sum of the random variables, right? Then you will be adding the number of persons, right?
Yes, sir.
Okay, then also you can convert it into normal distribution. How can you convert them?
Just we have to divide it by variance. And divide it by root of np into 1 minus 1.
Right. So that will be sigma by root n, no? When you are doing that sum, what you are going to do? The standard deviation, it will be sigma by root n. If you remember it properly, okay, I will tell you. Maybe I'll write it here. So, okay, suppose my random variable is y, which is x1 plus x2 until let's say x100. Okay, and I wanted to convert it into the standard normal, right? That is z01, right? Or sorry, not z01, so normal 01. How can we do that? Probability that y minus mu divided by sigma upon root n. Is that correct?
So here y sigma by root n.
It will be right. Okay. This central limit theorem, na? Have you seen that central
Yeah,
limit theorem?
yes, sir.
So if my y is the sum of
Yeah, yeah,
the
okay, okay.
IID normal
Yeah,
variables,
of
then
course.
it will be sigma by root n, correct, na? Then it will only convert into this normal 01. Actually, this formula comes from the central limit theorem only. So instead of doing this sum, what I'm doing is I'm taking divided by n here. Then again it will be the same, na? So what I'll do, the n mu will be your. So if you're taking y as sum, random variable, then your mean is what? N mu, na? There. Okay, I'll write it again. So suppose my y is x1 plus x2 to x100, correct? And all IIDs, so xi's are what? IID, suppose, okay, in this case it is binomial, right? So what will be the mean of y or expected value of y? It is n times expected value of x. Hmm?
Right,
Yes,
sir.
sir. Yes, sir.
So it will be np, or maybe I'll write n mu, correct? So for y, expected value of y is n mu. Then what will be the variance of y? It will be how much is because variance of x1 plus variance of x2, right? Then what is the variance of x here? Hmm? Sigma square by
sigma square by n.
Sigma square by n, correct? So what will be the standard deviation then? Sigma by root n. And what will do? Y minus n mu divided by sigma upon root n, right? This step you are going to do. So you can use this formula also, or else what you can do is you just convert this into this. You just divide it by n, then you will be directly getting this value x bar minus q upon, because that n will be cancelled it out.
Oh,
You can
oh,
do,
sir. So
uh,
if you write normal of NP, then you don't need to divide it by n,
yeah,
right?
yeah. So either you do that or you do this.
Yeah. Okay. Anyway,
The
you
answer
get
will
the same
go,
answer.
yeah, you will get the correct answer, the same answer you will get.
Oh, okay.
Because the final our goal is to convert it into this CLT, right? Central limit theorem, so that we can use the value of z, because we have to approximate it to the normal distribution, so that we can use this z values, right?
So finally, we're converting it to standard
Same.
normal.
Yeah, that is
Oh,
our goal, and that those are the only calculations we have to do. Otherwise, that alpha is, we know that reject h naught given that h naught is true. Beta is, we know that reject h naught, sorry, accept h naught given that h is true, or power is reject h naught given that h is true. That's it. Then you have to
yes, sir.
convert it into this standard normal, and then you can use the same calculations. Okay, but you got it right now. So
Yes, sir.
either you use the sample mean, or you can use this sum of the IID, random variables.
Yes,
Either
sir.
way, you'll get
Understood.
the same thing. Yeah. Okay. So these are the calculation here. So again, so you have to put this value of p equals to zero point 0.4 in the calculation, in instead of this p here. So if z is greater than c minus zero point 0.4 divided by root of 0.4 into 0.6 by n. So 0.4 into 0.6 is 0.24, which is equals to 1 minus fz of c minus 0.4 divided by root of 0.24 divided by n. Okay. So alpha is 0.95, which is equals to fz of c minus 0.4 divided by root of 0.24 by n. So c is equals to this. So we'll get this equation: root of 0.24 divided by n, fz inverse of 0.95 plus zero point 0.4. So this is your equation 1. Similarly, by using the value of power, so it is 1 minus beta, which is equals to 0.95 given. So 1 minus beta is reject h naught, that is x bar is greater than c, given that alternative hypothesis is true, which is p equals to 0.6. So again, similar calculations you have to do: x bar minus mu, that is 0.6, divided by root of p into 1 minus p divided by n. So same thing, c minus 0.6 divided by 0.24 uh, root of 0.24 by n. So if z is greater than c minus 0.6 by 0.24 by n, that value is 1 minus fz of this thing, okay, which is equals to 0.95. So 1 minus fz of this value is equals to 0.95, which is equals to 0.05 equals to fz of this value. So fz inverse of 0.05 is given in the question. So I think you can use that value here. So you'll get this equation: c equals to 0.24 by n, fz inverse of 0.05 plus 6, 0.6. So equation 1 is this, equation 2 is this. By using equation 1 and 2, you can find the value for n. So these are all the calculations here given here. You can do the calculations and you'll get n, which is approximately 65. So, and if you use this n equals to 65 in any one of the equation at either 1 or 2, you'll get the value of c. So value of c is 0.49. Okay, these are all the calculation. You just I will share the slides with you. You just check out with these values. Okay,
So where is equation 2?
here by using the power, right? We have found this
Okay,
equation number
okay,
2 by
okay.
using the power. Okay, so this is the question number 5. This will be the last question, I think. So yeah, a survey of 200 randomly selected students from a school revealed that 70% of them participates in extracurricular activities in schools. This is given. Can we conclude at 5% level of significance that 80% of the students participate in the extracurricular activities? Okay, yes or no? That is the question. So given that n is equals to 200, we know that probability of success is 0.7, alpha is given 5%, and 80% of the student participates in the curricular activity. I think this problem is of confidence interval. No, right? Yeah, I think. Yeah, no. Yeah. Just take some time and try to solve it, and we'll see the solution. That will be the last question. Okay, I think we should move to the solution. So yeah, so we have given the number of IID samples equals to 200. Alpha, that is significance level, is given as 0.05, and the null hypothesis is p equals to 0.8. Is it correct? Okay, it is. Yep. And h1 is p is not equals to 0.8. So given that the observed sample mean, that is x bar, is 0.70, and your null hypothesis is 0.8. So so z absolute is uh, 0.70 minus 0.80 divided by root of p into 1 minus p upon n, which is equals to 3.53. And we have given that alpha is equals to 0.05 and c is equals to 1.96. So 3.53 is greater than 1.96. We can reject the null hypothesis, and we cannot conclude that at 5% of the significance level, 80% of the students participate in the extracurricular activities. So this is just you have to find the value of z, and you have to compare it with the c. Okay, this is the statistic. You have to compare it with the c, and if it is not uh, if it is greater than c, then you have to reject the null hypothesis. Okay, any doubt in here? So this is also one of the alternative methods. You can use this also, but I think this is a shortcut method, so that will be better. But yeah, if you wanted to see the method 2, then it is again the same usual thing what we are doing. So it is x bar minus p, which is greater than c, given that p is equals to 0.8. Again, you have to convert it into this normal normal variate, standard normal variate, which is z is less than minus 50 c by root 2, and it is 2 times, because this was mod, right? Mod z is greater than some c, which is 2p z, which is less than minus 50 c upon root 2. So from here you can find the value of c as 0.05, and 0.78 0.70 minus 0.80 is 0.10, which is greater than 0.05. That is your c, and from that you can say that we'll reject the h naught. This is also the this is our normal method, and the first method was we can just directly compare the value of standard normal variate to value of c from significance level alpha equals to 0.05. So if it is 0.05, then your z that value of, because fz of 1.96 is 0.05, so for c equals to 0.05, uh, uh, your that zc is uh, 1.96. So 1.96 is lesser than 3.53, which is we found out by using this mod of x bar minus p divided by uh, variance, or sorry, standard deviation. So this is also one of the method you can use, or you can use our regular method. I hope this is clear to you. Maybe I think a lot of you are haven't studied this week, so I'm sharing the slides with you, all of you guys. Just study these slides and then try to solve the same similar question, and try it, practice it more, so that it will be easier for you to solve the questions in the final exam. Okay. So that's it from today's session. Uh, okay, shall we close now? Okay, guys, then if there are no more questions, then we are going to close the session. Thank you for joining the session today.
Thank you.
Yeah, thank you, thank you. Please solve these questions at your home. Okay, just I'm sharing the slides with all of you. Please solve it at home. Okay.
Sure, sure,
And any
sure.
doubts are there, please ask into the session.
Yes, sir.
Okay, okay, guys. Thank you. Okay, bye.